section 2.4, I have this split up into two videos here. First one has the first two examples. The first one is finding the sample standard deviation for the following data. So the part I have highlighted there is what you would be given. The rest of this, including the chart, and then the other work I'm going to show you, will all be stuff that you'll need to do. This column, however, deviation 1, will be optional. Some of you may be able to skip this if you're able to do this column and the third column all at once. So as you're working on this stuff, something to keep in mind. This one here, this one is optional. So if you're able to do it all at once, you certainly can. So you start out by listing out your values. Those are what we call our x's. So you're listing out the 24, 26, 28, 20, 16, and 25 that we have in the problem. And then you're finding the deviation and the squares. But before you can find the deviation, we need to know what this x bar is. So we've got x minus x bar. So x bar, remember, stands for your sample mean. It's called a sample mean because it's a mean found by the sample. So remember, to find that, you have to do the sum of your x's. So remember this notation here, one that looks kind of like a weird looking capital E. It means the sum of the x's divided by n, which n, remember, is your sample size. So your sum of your x's, if you add up all those x's there, if we find that sum here for all your x's, we get 139. So here on the top, we'd have 139. And in the bottom, in the denominator there, we'd have how many values we have. So in this case here, we have a total of 6 values. So we'd have it divided by 6 here. So let me write this a little bit better. There we go. So you'd have 139 divided by 6 to find the mean. So that should be something that you've seen before. Just add up the values, divide by how many you have. So you find the mean if you're dealing with just a small sample size. So here we'd get about 23.17 here. And then we use those to get the values in the table that I have there for the deviation column and the squares column. So you do the 24 minus 23.7, so I have that written in the parentheses there in the deviation column. You don't have to include that for these steps. In fact, I don't show that for the other ones, but that's how you're finding those values in the second column. So here it's easiest if you work just one row at a time. Do all the columns for one row at a time, so that way you can keep that value that you get for the deviation in your calculator, and then you can square it directly after that. So that way you don't have to re-enter it again. So you can do the 24 minus 23.17 to get the 0.83, and then square it. So remember, square it means you're raising it to the second power. Do not multiply by 2. Make sure you're raising it to the second power. Or you could also do the 0.83 times itself, another 0.83 to get that 0.6889 there. Likewise, for the next one, we would do the 26 minus this 23.17 for the mean to get 2.83. And then you square that to get the 8.0089. And then you follow suit. Do the same thing for each of those rows to get each of those rows there. Once again, if you're able to do that subtraction and then square it all in one step, certainly do so. That'll help save you some time. But if that's confusing you to skip that step, then write down that step as well for the deviation. That's up to you if you want to include that second column or not. After you do that, you then add up this column. So once again, this notation here means that you're finding the sum of that column. And the sum of that, we get 96.8334. So we use that to find our next value, our S squared. S squared represents your sample variance. Again, sample variance because we're dealing with a sample here, not a population. Do find these slightly different if you're dealing with a population than a sample. So for our sample variance, our S squared value here, we have to use that sum that we got there, the 96.8334, divided by, in this case, you divide it by 5. So this part down here, instead of it being an n like we had for the mean, it is n minus 1 in the denominator there in the bottom number. So that's how we get the 5 there. You see your sample size minus 1 to find a sample variance. If it was a population variance instead, population variance, remember this one here instead, that looks kind of like a O, it's called your sigma notation. That would be if you're dealing with a population rather than a sample. Most of our cases will be dealing with samples, because populations are normally difficult to get. So then if we do that sum that we had there, divided by 5, we get about 19.36668. For some reason, some of those 6's didn't turn out quite right. Get that to look a little bit better there. Once again, that was 19.36668. So again, for these, you want to go at least 2 decimal places. You can always go out more, so in this case, I went out more decimal places, but you want to go out at least 2 decimal places for these. And then once again here, this one was asking for the sample standard deviation. So that means we want S for our final answer. I'm going to abbreviate here, standard deviation. What we're finding here, our sample standard deviation to be more specific, okay? So to find that, just like the symbols show, you would want to do the square root of the variance. Because remember, to cancel out a squared, you have to do the square root. So here we do the square root then of that 19.36668. So there it looks like we get approximately 4.4008. And then that would be your final answer there. So once again, once you get started on this stuff, get those steps down. It isn't too difficult to do, it is just kind of time consuming once you get those steps down. So the hardest thing at first is making sure that you understand how to do the steps. Like normal, if you have questions as you're working on the problems in class, you can certainly ask, or you can stop by during my office hours. For the next one here, we're given a sample mean in the problem and the standard deviation. So here we have a mean of 69 and a standard deviation of 4.1. We want to estimate the percentage of heights between 64.9 and 77.2 inches using the empirical rule. So the empirical rule, another name for that you might see is the 68, 95, and 99.7 rule. So for that, those are the 3 percentages that we use there. The 68% means you're going out 1 standard deviation above and below the mean. So I'll put SD here for standard deviation. Because I don't have a whole lot of room here. 95 would be 2 standard deviations. 99.7, you would go out 3 standard deviations. Once again, above and below the mean. Because So we'll need that information in order to try and figure out the percentage between 64.9 and 77.2. So here, one way to do this is to draw out a picture here of the normal distribution curve. For some reason my Microsoft Word's acting up at the moment, so just a minute here. What we'll want to start with though, whenever we're doing this normal curve, is we're going to want to start with the mean of 69. It's going to need to go in the middle here. And then what you're going to want to do is to subtract 4.1 from the 69 and subtract the 4.1 from that 64.9 to get both your values below the mean. And likewise, you'll need to add 4.1 to those values to get your values above the mean there, because that'll help get how far you're going above and below the mean for these. So that way we can try and figure out what percentage is between that 64.9 and the 77.2 here. Not sure why it's taking so long to respond. There we go. Let's try and sketch it out here. So we'd have 69 in the middle, like I said, and then you subtract the 4.1, which is your standard deviation, to get one standard deviation below the mean. So if you subtract 4.1, we get 64.9. And then we can subtract 4.1 again to get the next value down, which would be 60.8. And then if we want above the mean, we'd add the 4.1. Of course, depending on how far your numbers go, you might have to go out 3 standard deviations instead of just 2. But our numbers aren't too far away from the mean here, so we really only need to go up to 2 standard deviations away. If your numbers are further apart, then you'll need to add more standard deviations in there. So we'd have 77.3 by adding 4.1, and 77.2 by going 2 standard deviations above the mean. So here what we have is that in between these two values here, so it looks like I didn't get it real symmetric. I didn't get the 69 exactly in the middle there. If it was a perfect picture, those would be the same distance on both sides of that curve. But we have about 68% in between those values using that empirical rule. The empirical rule says above and below the mean. One standard deviation above and below the mean is 68% approximately. And then we have above and below the mean by 2 standard deviations. So going 2 standard deviations out, we're going out to these values here. So we're going from the 60.8 to the 77.2 there is 95%. But what it's asking for in the problem here is from the 64.9 here, and we're going actually all the way up to the 77.2. So it's definitely going to be more than 68%, but it better be less than 95 because this does not include this region from 60.8 to 64.9. It does not include that region. It doesn't go down that far. So what we really need here now is to calculate what this region is in here, in between that 73.1 and the 77.2. So one way to get that, so let me switch back to black here. So one way to get that is to do the 95% that you have overall from 2 standard deviations from the mean, minus the 68, the percentage in between 1 standard deviation from the mean, and divide that by 2, so that way we just get that upper half of it. If we had just 95 minus 68, that would also include this lower half in between the 60.8 and the 64.9. But we just want this upper half here. So if we do that here, we get about 13.5%. So to get our overall value, once again, it has to be more than 68, and it better be less than 95, otherwise you did something wrong here if we're looking at that picture. So here we could do the 68 then, plus that 13.5 that we just got there. So if we do 68 plus the 13.5, for your final answer here, looks like we should get 81.5%. 81.5% here. Let me type it in there as well, since for some reason I'm not writing real well at the moment here. So I'll type it in here as well. If it will cooperate. For some reason it's acting up at the moment here. I'll insert as a text box here. So the final answer for this one is that 81.5%. Guess I didn't do it in the text box, but you can see it right here. This 81.5% there would be your final answer. So once again, whenever you're going through and doing these problems, make sure that you're breaking it up there into its simplest steps. So once again, this was using that empirical rule, the 68, 95, and 99.7% rule. Sorry about the technical issues Microsoft Word was having. But that would be how you could do examples 1 and 2, and we'll do example 3 here in the next video.